All right, welcome back, everybody. Today we're continuing our chapter on logic and reasoning. For 2.4, we've got a quick section on deductive reasoning, objective to use the law of detachment and the law of syllogism. All right, we'll explain what the heck that all means as we go through here. All right, so first up, deductive reasoning, I'm going to say is the process of reasoning logically from a given state or facts to a conclusion. Okay, so what we're going to do today is we're going to give you certain facts, okay, certain conditional statements, and we'll come up with conclusions based on the way we can chain those together. And real quick, we're going to start off by using the law of detachment. Now, you don't need to memorize the name for it. You don't need to memorize the vocab. We'll show you how it works in a second. But the law of detachment just says that if the hypothesis of a true conditional is true, then the conclusion is also true. All right, so let's give an example. Problem 1 says, what can you conclude from the given information? We're given two statements. If a student gets an A on a final exam, then the student will pass the course. Okay, Felicia got an A on her final exam. I'm going to say here I conclude that Felicia, all right, will pass the course. All right, there's my new conclusion. So that is an example of using deductive reasoning. And basically what we're doing here is linking two statements together logically to come up with a new conclusion. Okay, now the reason this works is our hypothesis of the conditional is a student gets an A on a final exam, is satisfied by Felicia. Okay, since she got an A, we know that she will pass the course. That's how I can chain those together. All right, B and C are the same idea. I'm going to say, though, one of them works and you can make a new conclusion, the other one doesn't. Why don't you take a minute, pause the video, try to work through those, figure out which one works, which one doesn't, and then make a conclusion for the one that does work. All right, part B, we're given, if there's lightning in the sky, then it's not safe to be outside. And Marla sees lightning from the soccer field. This one I'm going to say you can make a conclusion. Hypothesis is there's lightning in the sky. Okay, Marla sees lightning, so we'd say that Marla satisfies the hypothesis. So we can just say it's not safe to be outside, or for Marla to be outside. Okay, wording for these doesn't have to be exact. Okay, it's not safe to be outside, it's not safe outside, it's not safe for Marla to be outside. Okay, some version of that. All right, so C then must not work, because I said one will work, one won't. Okay, so C doesn't. And let's take a look at why. We have if a figure is a square, then its sides have equal length. And figure ABCD has sides of equal length. Okay, ABCD has sides of equal length. That does not satisfy my hypothesis. It matches the conclusion, but not the hypothesis. And with conditional statements, I can't go backwards. I can only go forward through them because this statement's not necessarily true as a converse. And in this case, it wouldn't be true as a converse. Okay, if a figure has sides of equal length, then it's a square. Okay, that's false. A equilateral triangle has sides of equal length, and it's not a square. Okay, so I can't work backwards through this. So I'd say no conclusion. I can't make any new information or gain any new information from the given statement. All right, other law we're going to talk about is the law of syllogism. Now again, don't memorize this word, don't memorize the definition. We'll show you how to use it in a second. But what it does is allows you to state a conclusion from two true statements when the conclusion of one statement is the hypothesis of the other. Okay, so let's show you how that works here. All right, so statements I'm given are if a figure is a square, then it's a rectangle. And if a figure is a rectangle, then it has four sides. Okay, I'm going to say that I can chain these statements together, I can link them together, because it is a rectangle is the conclusion of my first statement, and a figure is a rectangle is the hypothesis of my second. So what I can do is kind of skip out the middle and go straight from beginning to end. I can say that if a figure is a square, whoops, then it has 4 sides. Okay, so again, since the hypothesis and conclusion matched up, I could link these two statements together. And this would work in either order. Doesn't matter what order I'm giving these statements in. If one hypothesis matches the one conclusion, we can link them together. Okay, again, B and C are the same idea. I'm going to say one of those will work, one won't. Why don't you take a minute, pause the video, okay, give B and C a shot, figure out which one works, and come up with a conclusion for the one that does work. All right, in part B, we're given if a figure is a square, then the figure is a parallelogram. And if a figure is a rectangle, then the figure is a parallelogram. I'm going to say that this one is my no conclusion example. Okay, reason for that is these two statements do match up, but we have the figure is a parallelogram and the figure is a parallelogram in both the conclusions. Okay, so I can't actually link hypothesis with conclusion, okay, because we have matching conclusions. To use the law of syllogism, we need one matching conclusion with another matching hypothesis. Okay, so again, this one won't work. They're both true statements, but I can't conclude anything new from them. All right, so that means part C will work. Let's take a look at what we have. If a number ends in 0, then it's divisible by 10. And if a number is divisible by 10, then it is divisible by 5. Okay, this works because the conclusion of one statement matches the hypothesis of the other is divisible by 10. So I can go straight from if a number ends in 0 then it is divisible by 5. Okay, so again, since one hypothesis matches one conclusion in either order, we can chain those statements together by kind of skipping out on the matching part. And last thing we're going to look at is how we can combine 3 or more statements together to form conclusions about just basically more complicated situations. So here I've got 3 statements along with a map to kind of help me picture what's going on. And what I'm going to do is look to combine them all to come up with a new conclusion. Okay, so here we're given if you live in Accra, then you live in Ghana. If you live in Ghana, then you live in Africa. And let's say this is Asa lives in Accra. Okay, when I put all those together, I'm going to say I can conclude that Asa lives in Africa. Problem with my pen there a second ago. And the reason I can do that is we have Asa lives in Accra. So that's satisfying my hypothesis. You live in Accra. Therefore, I conclude that they live in Ghana. And if you live in Ghana, we know you live in Africa. Therefore, I can put all 3 of these together and say that Asa lives in Africa. Okay, now it would also be correct to say that Asa lives in Ghana, or if you live in Accra, then you live in Africa. But what we want to try to do here is combine everything into a single statement, okay, combine as much as possible. Okay, part B is the same idea. Why don't you take a minute, read through those 3 statements, come up with a conclusion, okay, hit pause, come up with that conclusion, and then hit play to check your answer. All right, for part B, we're given if a river is more than 4,000 miles long, then it's longer than the Amazon. If a river is longer than the Amazon, then it's the longest river in the world. The Nile is 4,132 miles long. Okay, so the Nile satisfies our hypothesis Therefore, it is longer than the Amazon. And we know since it's longer than the Amazon, it is the longest river in the world. Therefore, I can say the Nile is the longest river in the world. All right, so there you go. There's 2-4 deductive reasoning. Pretty straightforward. So start working on the homework, start cranking out some problems, and like usual, if you get stuck, we're here to help you out.